Welcome to The Explainer. Today, we're diving into something huge. One of the biggest challenges we face, managing our planet's water. It's a really complex story, you know? It's about balance, conflict, and a whole lot of human ingenuity.
So let's start with the big question that really affects all of us. How do we handle this vital resource? It seems like we're always dealing with extremes, right? You've got devastating floods over here, and then crippling droughts over there. And on top of all that, the water we do have is often too polluted to use. So yeah, how do we find a path forward that actually works?
Okay, so the first thing we really have to get our heads around is that water isn't just for drinking. I mean, think about it. It has so many different jobs. We need it for absolutely everything. It's powering our cities with hydroelectric dams, it's growing our food, it's running our factories. Heck, it's even a highway for transportation. And here's the kicker. Every single one of those things is pulling from the exact same limited supply. That creates this constant, intense competition.
And that competition, when you throw in how fast the world is changing, well, it leads to what you could call a triple threat for water planners. These are the big, core problems they're wrestling with literally every single day.
So, problem number one, just not enough water. Scarcity. You see, as our cities get bigger and new industries pop up, our need for water just skyrockets. Then, when a drought inevitably hits, what used to be a manageable situation can turn into a full-blown crisis fast. And that forces some really tough, painful choices about who gets water and who doesn't.
And then, on the complete flip side, you have the second threat. Way too much water all at once. The problem is, as we develop more and more land, especially on natural floodplains, we're basically putting more people and more stuff directly in harm's way. So when those floods do come, and they always do, the damage is just magnified. It's more devastating than ever. And the third threat, this one's a bit different. It's about the quality of the water we actually have. You know, things like industrial waste, pesticides from farms, even the wastewater from our own homes. It all gets into our rivers and groundwater. And that pollution can make the water totally unusable, completely unsafe. So even when it looks like there's plenty of water, this threat is secretly shrinking our real usable supply.
Okay, so you've got these three huge, intimidating challenges. Where do you even start? Well, the key, the real breakthrough, is a shift in thinking. We have to stop looking at a river as just, a line of water on a map. We need to see it for what it truly is, part of a much, much bigger interconnected system.
So what exactly is a water system? Well, it's not just the river. It's everything. It's the entire river basin, the rain that falls, the water under the ground. It's the cities and farms that rely on it. It's even the laws and regulations we put in place to manage it. The crucial part is that all of these pieces are constantly interacting with each other, affecting each other, in a giant, complex dance.
To make sense of all this, planners usually break it down into three main parts. First, you've got the natural system. That's the river itself, the physics, the biology. Then there's the socioeconomic system. That's us. It's our farms, our cities, our industries. And finally, you have the administrative system, all the governments and laws trying to manage the whole thing. But here's what you absolutely have to remember. They are totally interdependent. You can't separate them. And new law could change how farmers use water, which then directly affects the river's health. It's all connected. You can't just tinker with one part and expect the others to stay the same.
Now, what's really fascinating here is to look at how our approach to managing these things has changed over time. If you look back, we've basically tried two very, very different paths to get this right.
So on one hand, you have the old-school top-down approach. This is where a small group of experts in a central office would cook up a big master plan for everyone. The problem? It often completely missed what was actually happening on the ground and ignored what local communities knew and needed. The big shift, the modern way of thinking, is the bottom-up approach. And it's exactly what it sounds like. It's about bringing everybody to the table. We're talking farmers, city folks, environmentalists, industry leaders, everyone. They all work together to build a plan. And that's genius, because it means everyone is invested in making it work, because they had a hand in creating it.
And this whole idea, this collaborative bottom-up way of thinking, it's led to what's pretty much considered the gold standard today for managing water.
It's called Integrated Water Resources Management, or IWRM for short, and the name says it all. The goal isn't just about managing the water itself. It's about coordinating everything connected to it, the water, the land, all of it, so we can maximize everybody's well-being. But, and this is the crucial part, without destroying the very ecosystems we depend on. It's a completely holistic way of looking at the problem. So, this whole approach is built on 3 core ideas, often called the Dublin Principles. First, the ecological one. You have to treat the whole river basin as a single system. Can't just look at one part. Second, the institutional principle. You've got to involve everybody: government, private companies, regular citizens. And third, the instrument principle. You have to recognize that water has an economic value. That helps us be more efficient with it. Now, this might sound logical to us today, but at the time, this was a revolutionary shift. It changed the conversation from water is just a thing to be controlled to water is a living system with ecological, social, and economic value that needs all of us to manage it.
Okay, so that all sounds great in theory, right? But how do planners actually do this? How do they put these big ideas into practice and try to predict what's going to happen in a system that's so incredibly complex?
The answer is they use models. Now, a model is basically a simplified, often digital version of the real thing. Think of it like a flight simulator, but for a river basin. It lets planners ask all sorts of what-if questions, like, what if we build a new dam right here? Or, what if the next drought is even worse than the last one? Now, these models don't spit out a perfect decision. That's not their job. What they do is give us critical information. They help us see the potential consequences of our choices before we make them.
And you have to understand the stakes could not be higher. We're talking about projects like huge dams or massive irrigation systems. These things are enormous. They're basically permanent. They cost a fortune, and they completely reshape societies and economies. That's why this whole systems approach, using models, is so essential. Because even a tiny improvement in how we plan can lead to incredible benefits and, more importantly, help us avoid truly catastrophic mistakes.
Which, brings us right back to where we started. Because even when you have the best systems, the best principles, and the most sophisticated models, you're still left with a very human question. A city needs water to drink, a farm needs water for our food, and the river itself needs water just to stay alive. Every one of those needs is valid. So the real work of water management, the job that never truly ends, is trying to balance all of it. It's a constant search for a solution that isn't just smart or efficient, but one that's fair and sustainable for everyone, now and for generations to come.